Hello everyone. Today we will discuss Leetcode Volume 208 implement trie. And so basically we are required to implement a trie data structure. So let's first understand what a trie is and what it is used for. Okay, let's understand this with an example. For example, if we are given a long array of strings, assume these are not words, variable names. These are strings, and we are given this big array of different strings, and we want to find if a specific set of characters is present in this whole array. That means, suppose if I want to see if there is an array contain monkey, if the word monkey is inside this array or not, and we want to find it efficiently. So one way is to compare that new word, that is monkey, with every string in this array, and that will cost us O of m into n time complexity, which is not that good. We can make very much improvement using a trie data structure. For example, we will just convert this whole array into a trie. But before that, let's understand what a trie is properly using this example.
So let's say we have to store these set of strings. If we store this inside an array, we will use n times m space, where n is the number of words and m is the average length of each word. But if we notice that all of them starts with MAC, so instead of storing multiple times character MAC, we can just store them once and attach to them the words that starts with it. Similarly, we can see that ACO, acrony and Arun all start with A, so we can combine these also and attach the remaining part. Similarly, if we do this with all the characters, then you can see that we have saved a lot of space. So uh, what we just did is that we have built the trie of these words, where each root to leaf path represents a string, right? So now what is trie? So trie is a tree data structure that takes advantage of strings that have the same prefix and store it once. Okay, so let's see the time complexity. Now if we store this in an array, the time complexity will be O of n into m, where n is number of strings and m is the length of search string. But in trie, the time complexity is O of m, where m is the length of search string. For example, if we search for macaroni, here we start with the root and move to MACARONI. So by this, we have taken only O of m time and we have found our word. In a trie node, we want to have three information: the character, the references to children, and a boolean to represent that there is a word ending with current node.
Okay, so now let's try to convert this. For example, whenever we encounter this word macaco, so we will have a tree at the top level, and I can say that okay, I found an M here. Then I will say at this top level. Then at the second top level, I also found an A, and then I found a C. Then I found a MSCA. Then again a C, and then again and then an O, and I will now assign a boolean value that okay, my string ends here. So let me just write an infinite sign here for that. Okay, then the next word is macaroni, so MACA, and next we have C, so this A will point to two nodes, RONI, and then I will mark a boolean or something like that to make sure that okay, my word ends here. So now if I had only these two, okay, let me make one more word here, macaroon, MACAROO. Okay, double O will point to another node, and then N, and then I will mark a variable something like that, so that I can say that okay, one word ends here. So if my array was still here only, and now I want to search for monkey, then I can see that M only points to A, and I will stop here that okay, there is no such word with monkey. Or if I want to search for macaroni, then I will keep traveling. Okay, I found A, then C, then A, and if I hit here like that, then I will be sure that okay, I found the word here. So I hope you were able to understand how we use trie data structure properly. Now let's see the code. I have written a Python code. So basically we will need a tree data trie node data structure, and it is something, and I will store the collection this node. For at every node I will store the number of children that are in of that node, and I will initialize self dot root equal to tree node. So basically every time I call this try, a new tree node, and this node will be created. So and now I will try to insert a word. First I will find the root, and once I found the root, I will append. I will just keep on inserting the word like this. For letter in word, for every letter, current equal to current dot children. In this children, I will add this letter, and current dot is word equal to true. So like that, and this is the search function. You can read it. It is very simple to understand. You were able to understand till this point. It is just the implementation of that. And similarly, we can also code a function for starts with. In the search we have to check if that last, suppose if I want to search for macaroon, then I have to travel this whole path, and I have to check if this last was the false or true, like that. Whatever it is implemented here is word equal to false, and then I have to say that is word is equal to true at the last. And for starts with, I have to check if the I don't have to check this final condition, and next I can return and I can return true while traveling only once I have found the whole word. So I hope you were able to understand that. So thanks for watching. I will see you guys next time.